We are given the following stress field, and we want to determine whether it will satisfy internal equilibrium or not. Now, in order for this to be true, all 6 of these stresses have to satisfy all 3 equations. So we need to satisfy all 3. So essentially, if one is not true, then it is not a physical stress field. So pretty much what we have to do is we have to go equation by equation and just take the partial derivatives to see if they come out to be 0. Now, if there's a remainder, we'll essentially set that equal to these partial body forces here. So that could be gravity, that could be electromagnetic forces, it could be something along those lines. So if we're in a system where we have no gravity or we have no EM forces, then they should technically all be 0. But if they're not, we'll essentially set the remainder equal to the 3, and then we'll have to say this will be satisfied as long as these body forces are blank, blank, blank. And we'll go through that. So let's start off by numbering these equations just to make life a little bit easier. And we can start by solving equation 1. So we're taking the partial derivative of sigma x with respect to x. So sigma x is 3x squared. So taking the derivative with respect to x will give 6x. And then we're taking partial derivative of tau xy with respect to y. So that will give negative 6x. So those two will cancel. And then, last but not least, we'll add the partial derivative of tau xz with respect to z. And this will have 0. So then we'll have plus fx, and this will all be equal to 0. So then fx will be inherently 0. So that's 1 down. So just 2 more to go. So now for number 2, what can be done is for the partial derivative of tau yx with respect to x, that will give negative 6y. Then we'll take the partial derivative of sigma y with respect to y. That'll give plus 2y. And then partial derivative of tau yz with respect to z, that'll give negative 2y. So those two will cancel, and we'll have plus f sub y. And then that should equal 0. So then that'll leave that f sub y is going to be equal to 6y. And then for equation 3, so we have the partial derivative of tau zx with respect to x, so that will leave 3. And then partial derivative of tau zy with respect to y, that will leave minus 2z. And then partial derivative of sigma z with respect to z, so that will leave positive 2z. So then these two will cancel, and we'll have plus f sub z equals 0. So then f sub z is equal to negative 3. So we can essentially say, yes, this will satisfy, or this will essentially satisfy internal equilibrium if our body force vector F is equal to 0, 6y, negative 3. So we're essentially taking our fx value, fy, and fz value, and we're putting that into a column vector. So essentially this stress field of these 6 stresses will satisfy internal equilibrium if the following body vector or body force vector is true.